Right on, right on, right on. Alright, so does anyone have any questions at all? Really? No one wants to see how fast they can go?
Can I drive the bus?
Alright, we're going to try out full speed, okay guys?
Okay.
1, 2, 3, go! And this is as fast as we go in this bad boy. Tops out at about 18 kilometers an hour. Not really built for speed, but you know, speed nice over to mix that all together, so I think we're pretty good right here, hey? Yeah, so these guys manufactured, they will go about 30 kilometers an hour, but then once we get them here, we put a governor on them for operation. It just makes sense, you know, you carry around 56 people, you don't really need to be speeding on ice. A question I get quite often is how deep is the ice? So the glacier you're standing on back there is roughly about 250 meters deep, or about 840 feet. Yeah, that's some ice. Now, glacier is also 5 kilometers long, 1 kilometer wide, and about 250, oh yeah, sorry I said that. 1 kilometer wide, and 5 kilometers long. Now, the surface area of this glacier is only about 2% of the size of the entire Columbia ice field. So you would need 50 of these glaciers to cover the entire Columbia ice field. And this glacier is pretty big, right? So you can imagine how big the ice field itself is if you need 50 of these to cover it. Now, people often ask, when do we operate? So do we operate for all year, or do we close down for the winter? So the answer is yes, we do close down for the winter. We go from about mid-April to about mid-October. Now after October, it's just too cold up here, and the weather conditions start to get pretty adverse. So I'm talking, we can get snowstorms just like this, just like out of nowhere, and they're whiteout storms that drop several centimeters, if not inches of snow. And then on top of that, once the middle of winter is here, you've got road closures due to avalanches and winter storms, and you also have the fact that you can get temperatures as low as minus 47 degrees Celsius here. So all together, you don't really want to be out here in the winter. It's not the best place to be in the winter, but there are some people that will come down this way. So some of the most seasoned mountaineers, so they come out here because they want to go mountaineering. They want to climb the mountains around here. Now, you can do a lot of approaches from the front on these guys, but a lot of it requires some serious rock climbing. Now, if you do an approach from the backside, though, with a lot of them, it's actually much easier. The problem is this time of year you can't do an approach from the backside because the snowpack isn't good enough on the ice field or on the glacier to get up there. So what I mean by snowpack is once snow falls on the glacier here, it's going to cover up a lot of those cracks and holes. And then once they're covered up, if enough snow falls on top of them, they actually have pretty solid snow bridges over top. So to the point where you can actually walk over top of them in some areas. Now I'm not saying that it's guaranteed that they won't break, but it makes it a lot safer an alternative to what we have right now, which is a snow bridge that will break or no snow bridges at all. So it is a little bit better for them in the winter. It is much colder, so typically they'll come during the springtime, so they can do it during the spring. Now, people often ask me why the glacier looks blue in some areas. So the glacier looks blue because of how dense the ice is. The ice is very, very dense and it has no air bubbles in it, so it's acting as a prism. So real life examples of prisms you may have seen already. You got rainbows. Pink Floyd, Dark Side of the Moon, the album cover. That's what I got for you. Now as white light enters into the glacier, here it's going to be broken into that visible spectrum with the longer wavelengths of light, which is our yellows and our reds. They're going to be absorbed in our shorter wavelengths, your blues, they're able to escape. And that's how we see the blue in the glacier. Now there's different colors of ice. You can get white ice that is kind of white or gray. That ice has been thawing and refreezing, so it's got a lot of air bubbles in it. And then some glaciers, you'll be able to find ice that kind of looks red. It's not actually the ice that's red, it's what's living in it. So bacteria lives in the surface of the glacier, and it has a pigment in it that changes the color of the snow and ice in which it lives to be a little bit of a reddish pink. Now it's called watermelon snow or watermelon ice because apparently if you pick it up and squeeze it and smell it, it smells kind of like watermelons. Pretty cool. Now if you happen to stumble across yellow snow or ice, do not be mistaken, folks. That is not going to smell like lemons. 'em. Alright folks, so down on the left in the valley there, these are people walking on the glacier. Those people walking on the glacier should not be there. That is a bad idea. So the only way you should go walking on the glacier is if you are well trained and you have the proper equipment, or if you're being guided by someone who does have the proper equipment and is well trained. You should never go wandering on the glacier on your own like that. It is very, very dangerous. Those cracks are absolutely gigantic and you cannot see a lot of them until it is too late. So those people down there right now, they're literally risking their lives for a little walk on a piece of ice. So don't do that. Don't do that. Be smart, all right? So down on our left in the valley there, you guys can see San Juanito Lake. Now San Juanito Lake has so the reason for the coloration in the lakes around here is due to something called rock flour. So what rock flour is it's a very, very fine sediment that gets left behind by the glacier. So as the glacier moves down through the valley, it's going to grab rocks and grind them against each other. It breaks them into a very, very fine powder, and that's why we call it rock flour, because it does very much resemble flour you would use back at home in your kitchen for baking a cake. And it's very fine, it's soft to the touch. However, it would not taste very good if you made a cake with it. Also, it's a natural laxative, so I mean, you might end up in the bathroom for a little while there. But that's what you're going for. I mean, by all means, bake your cake. Otherwise, I'd probably leave it where it is. So it ends up in the lakes and streams, and it floats around in the water. And as it sits suspended in the water, light's going to shine into that water, reflect off those, reflect the shorter wavelengths off of those little tiny particles of rock floating in the water. And that's how we get those cool colors. So we get our blues and our greens getting reflected back out of the water. Now, so Lotto Lake down there, it has a lot of rock flour in it. And it's so much in fact that it is slowly filling up. So there's 4 glaciers in the area that add water to that lake. So you got the Athabasca Glacier, you got the Andrews Awesome Glacier, and you got the Andromeda Glacier. And then you also have one on the front of this mountain straight ahead of us, and that's called the North Base Glacier. And so all 4 of those have meltwater going into that lake and are adding rock flour to that lake. To the point where so much rock flour is being deposited into it, and in about 20 to 25 years, there will be no more lake left there. It will just become part of the river channel leaving the area here.